Hello everyone. So welcome you all to post-contest discussion of Leetcode Weekly 405. And let's start with the discussion. So we are going to cover all the problems in the order in which they came in the contest. So starting with the first problem, the name of the problem is find the encrypted string. It's an easy problem, and if you look up to the problem statement, it goes as you are given a string s and an integer k. Encrypt the string using the following algorithm. For each character c in s, replace c with the kth character after c in the string, and you have to consider it in a cyclic manner. And at the end, you need to return the encrypted string. For example, if you look up to this first input that is given to us, the string is DART and the value of k is 3. So if you look up to the first character is nothing but the third character after index 0 in the string. So if you look up after D, what is the third character? The third character is T, right? A is the first character, R is the second, and T is the third. So T comes over here. Now, if you look up to the third character after A, that is at index 1, the third character after index 1 will come. So, the third character after A is, the first character is R, the second character is T, and the third character is D because you need to consider it in cyclic manner. The thing is that if you are given a string something like this, D-A-R-T, so now the third character after D is T. The third character after A is, if you look up, R is the first character, T is the second character, and then you need to consider it in cyclic manner. So D is the third character. So D will come over here. Now, similarly for R, what is the third character after R? So T is the first character, then D is the second, and A is the third. So A comes over here. Now, similarly talking of T, so third character after T is, D is the first character, A is the second character, and R is the third character. So R comes over here, and this forms your answer string. So this is a question for you, that you have been given this string and you need to find out this answer string. So how you can do this? How to do that? So it was a very easy problem for observation perspective. So if you look up, this is if you are talking of any index I, and you are given that this string s is of length n, and you want for this ith character, what you want? In actual, you want the kth character after this ith character, isn't it? This is the question. So what basically you need to do is, if you look up, if this I is, let's suppose 0 and k is 3. So what would come in answer of 0? That is, if you are forming a string, what would come in the 0th index? It would be basically 0 plus 3. The index of the answer character would be I plus k, isn't it? So it would be 0 plus 3, that results into 3. So if you look up in this string s, the third character is T, so T comes over here. Similarly, talking of character A. So for character A, the index I is 1 and k is 3. Now, if you do I plus k, you would get 4. And if you try to access 4 in this string, you would do a blunder, isn't it? So if you look up, what was the answer? What was actually the answer for A? The actual answer for A was D, isn't it? So if you look up, if we simply calculate I plus k modulo n, in that case, we would get 4 modulo 4, which is 0. And the character at the 0th index of the string will be our answer. So can we say that for any ith character, I plus k modulo nth character in the string will be our answer? And why is it working? Why we are able to do that? Because we need to consider the string in cyclic order. So can we say that string is nothing but if we have DART, something like this, and since we are told that we need to consider the string in cyclic order, so it is basically the same thing, that we have many strings, something like this. We have DART again, we have DART again, we have DART again. Now, if I tell you that after A, I want the third character. So if you look up, R is the first character, T is the second character, and D is the third character. So we get D as our answer, and the job is done, isn't it? So if you look up, this the index of this D is nothing but I. If this is of index I and we are looking of the kth character after I, then it's nothing but I plus k modulo n. Because if you do modulo n, the indexes will be in the range of 0 to n minus 1. And this is actually the range of indexes in a string having length n, isn't it? So yeah, that was the pretty much the easy solution for this. Let's see the code. Yeah. So this was a function given to you, the string s and the integer k. Then you constructed an answer string. Okay. Why you are not making the changes in this particular string DART only? That may be the question that many of you would have got. Okay. So if we have DART something like this, and if we, let's suppose, make this D as T right over here. Now when we try to access the answer for this character A, we would get T, isn't it? So for constructing the answer string, for constructing the answer, you need to maintain one other string. Because for this A, the answer is D, which is actually the 0th index character in the original string. So you don't want to modify your original string, isn't it? So what we did for that, we constructed another variable answer and took the size of this string in the variable n. Now we traversed over all the characters and we know that for answer, the ith character will be nothing but the I plus k modulo nth character in the original string. So in our answer, we simply added that thing and we are simply returning the answer. Yeah. So that was for the first question. Let's move on to our second question for the day. Okay, so this was the second question. Again, pretty much easy solution and very much helpful for the ones who are just starting off with the recursion. So it's very much the question for them. So the name of the question is generate binary strings without adjacent zeros. So let's go through the problem statement. You are given a positive integer n. A binary string x is valid if all substrings of x of length 2 contain at least 1, 1. Return all valid strings with length n in any order. So first of all, let's understand the question and then we will look up to the constraints. The question says that we have been given some integer n. We need to construct a string s of length n, and this string will consist of only zeros and one character, like character 0 and character 1. And they have told that if we are considering any substring of length 2, it should contain at least one character. Okay. So like if we are considering this string, we should have at least 1, 1. Like we should have at least 1, 1. Like this is possible. This is possible. Again, this is also possible. But if you look, something that is not possible is this. Because if we have 2 zeros consecutively, then if we consider this as a substring, we would not get at least one character in this. And the question demands is that if we are considering any substring of length 2 in this string x, then it should contain at least 1, 1. Isn't it? So from this statement, we are pretty much clear that we don't want consecutive zeros. So consecutive zeros is not allowed, isn't it? Now, let's look up to the constraints. Let's look up to the constraints. So if you look, the very much helpful part for this question, the thing that makes this question very easy is the constraints. You are given the length of n as 1 to 18. This means that the maximum length of the string that you need to be constructed is only 18. So how can we do this? Okay, so we are told to construct a string of length n, isn't it? Now let's think of on the basis of index perspective that for every index, what character we can put up. If let's suppose I tell you that at any ith index, I am putting up 1. Okay, if I tell you, will you say me that Harsh, you can't pick it? Like you can't keep 1 over here. Will you tell me? Just think. You will not tell me, right? Because even if I am keeping 1 over here, I don't have any restriction that what was the previous character or what is the character I am going to put forward, isn't it? But If I say you that I am putting 0 over here, then you would say that, okay, be careful. Why? Because if I am putting 0 over here, so it is mandatory that the previous character should be 1 and not 0. Isn't it? Just try to think. If the previous character is 0, we would get a blunder, isn't it? Because if that is the case, we would get 2 consecutive zeros in our string and that string will become invalid, isn't it? So every time we are putting 1, we don't have any restriction. Every time we are putting 0, we have to be a bit careful. So for every index, for every index, we have 2 options, isn't it? Like putting 0 or 1. And while putting zeros, we need to be a bit careful. And by putting 1, we are free. Like we can put 1 anytime, isn't it? Okay. So for that, what we need to do is we need to know that what was the previous character. If we are putting 0, we need to know now that what was the previous character we put up. So we can maintain some variable, let's say f, and we can make that f as 1 if let's suppose we have put 0 before, and 0 if we have put 1 before. By that what I mean is, let's suppose we have something like this. Now you have put 0 over here. No matter what you have put over here, let's forget this. If you have put 0 over here, okay. Now the next character that you're going to put up, there is a restriction that you can't put 0 over here. So what you can do is you can maintain a variable f and mark it as 1. Once you mark it as 1 and come to this particular index, now you know that you can only put 1 over here and you can't put 0. Okay. Now let's suppose we put 1 over here. Once we put 1 over here, just tell me, what are the options for this particular index? This particular index is allowed to take 0. This particular index is even allowed to take 1, isn't it? So the value of f for this particular index will be 0. This means that there is no restriction in this particular index. So one time we will put 0, get all the possible strings via that. The next time we will put 1 and get all the possible strings via that. And by that way, we can get all the possible combinations, right? Now the question is how to generate the strings, like how to get all the strings. So for that, what you all can do is you can initially maintain some empty string temp. Okay. Every time you put on the character, like let's suppose I put on 0 over here. So in my temp, I simply add a 0 and just pass on the baton to the next index. So now I will just fill up the next indexes. Like let's consider some small examples so that all of you can understand. Let's suppose we need to construct a string of length 2. Okay. Now, for the first index, just tell me what will be the value of f. The value of f will be 0, isn't it? Because we don't put up any restriction what the value of first index can be, isn't it? Because it can be 0, it can be 1. And initially our temp is 0. Okay. So initially our index is 0. Our string is empty and the value of f is also 0. From here, I have 2 options. Either I put 0 over here or I put 1 over here. If I let's suppose put 0 over it, this is actually my index. This is my string and this is the value of f. Now if I put 0 over here, so my index will shift to 1 definitely. My string will become 1. But my value of f will change to 1 because now I have a restriction that I can't write 0 in the next index, isn't it? Similarly, if I put up 1 over here, my index will shift to the next index. My string will become 1. Okay, sorry, I put up 0 over here. Okay, so my string will become 1 over here, but my value of f will remain 0 because for the next index, I don't have any restriction. I can put either 0 over there or 1. Now, again, coming to this possible recursion, recursion call. So if you look, the value of f is 1. This means that we have only one option that we can only put up 1. So if we do so, our index will shift to 2. Our string will become 0, 1. And my value of f will change to 0 because for the next index, since I have put 1 over here, so for the next index, I don't have any restriction. The same thing if we do over here, since we have the value of f as 0, we have 2 possible calls. So when we make a call to our index increases, our string becomes 1, 0, and the value of f will now become 1 since we have put 0. So for the next index, there is a restriction. Similarly, if we are putting 1, so again, the index shifts to 2, the string becomes 1, 1, and my value of f will remain 1. My value of f will remain 0. I still have no restriction for the next index since I have put 1 at the end, isn't it? Now, if you look up, we require to construct a string of length n, and we already have that. We already have reached our index to n. So in this case, we can maintain some vector answer, and to this answer, we can push back this temp. So we push back this temp, isn't it? So the answers will be 0, 1, 1, 0, and 1, 1. So this will be our final answer, isn't it? Yeah. So let's see the code now. Wait a minute. Okay. So what we did, we constructed the vector string answer, and we are going to pass this answer to our helper function. In the helper function, we have the size of which we need to construct the string, the value of f, which is initially 0 because we know that we don't have restriction initially. We have this answer, and we have this initial empty string. Okay, and at the end, we are returning the answer. That is, all the possible strings, all the valid strings are getting pushed in this vector string answer. So let's look up to the helper function now. So this int n is the length of which we need to construct, it's still left to construct a string. Int f, the value of f, vector string ampersand answer, because we are going to update this particular one made answer only, and we have a string temp. If n is 0, this means that we are done completing constructing the string. So in that case, to our answer, we can push back this valid string temp and simply return from here. If this is not so, the value of n is not 0. So what we can do, we can check that what's the value of f. If the value of f is 1, if f is true, this means that we have a restriction that we can't put 0 to this particular character. So in our temp, we simply pushed back 1 and passed the helper function with n minus 1. The value of f now becomes 0 because now for the next character, we have options that we can either put 0 or 1, the answer string, the vector answer string, and this string temp. Else, if this was not the case, so we have two options. We can either put up 1 or 0. So first of all, we made a call by putting 1. If we are doing so, the value of f will remain 0. The value of n becomes n minus 1. Answer temp remains the same. In our temp, we are simply pushing back 1. Once we are done formulating with 1, so now we want to try by pushing 0, isn't it? Because there were two possible options. So we simply popped back 1 and pushed back 0 and made our recursive call to the next, isn't it? So once we do so, in our temp, till we reach n equals to 0, we will get all possible strings, all possible valid strings, and that we are pushing back to our answer. And at the end, we are returning the answer. So yeah, that was for this question. It was like pretty much easy to understand and like it was pretty much easy to solve as well by looking at the constraints, because it was simply at the time we had either one possible option or two possible options, isn't it? So in the worst case, the time complexity will go up to 2 power 18, and that is like will pass looking to the constraints, isn't it? Okay. So yeah, let's move on to our next question for today. That is the third question. Count submatrices with equal frequency of x and y. So it was a very classic implementation of 2D prefix sum. Yeah. So you all should know what is prefix sum. Prefix sum was a prerequisite for this. So let's go through the question once. Given a 2D character matrix greed, where greed I of j is either x, y, or dot, you need to return the number of submatrices that contains greed 0 of 0, an equal frequency of x and y, and at least one x. So let's understand the question by taking this particular input. Okay, so we have greed something like this. We have character x over here, character y over here, and character dot over here. Next, we have character y over here, character dot over here, and character dot over here. Okay. Now, if you look up, what we want, we want to construct the submatrices. What are the conditions? The condition is it should contain grid of 0 of 0. That is, the first block should be included. It should be included in that submatrix. Okay. So this is a mandatory condition. The second mandatory condition is it should contain at least one x. At least one x is again a mandatory condition. And the third and the last condition is that the frequency of character x in that submatrix should be equal to frequency of character y. That is, if I am including this submatrix, if you look, I am including this submatrix. So if you look, this submatrix contains this particular first block. Next, it contains at least one x. And the frequency of character x in this particular block is 1, and frequency of character y in this particular block is 1, so it should also pass. So since all the three conditions are passing, we can say that this is a valid submatrix. Isn't it? Can I say that this is a valid submatrix? This 2 cross 2 submatrix, is this a valid submatrix? Let's look up. It contains first block, okay, that condition is passed. It contains at least one x, okay, that is also passed. But if you look up to the frequency of x in this submatrix, it is 1. And the frequency of y in this submatrix, it is 2. And since they are not equal, it is not a valid submatrix. Okay. So that's the question for you. Now, how we can solve this? So the idea behind this question was prefix sum. And the reason was that we were told to include grid 0 of 0. Now, if you look up, if we are including the first block, can anyone say me that, can anyone just think that if we are including the first block, so what are the submatrices we can form? We can form submatrix something like this. Now, we can either get this, we can either get this, we can either get this, something like this, something like this, or something like this, something like this, or something like this. So if you look up everything, if we are considering, let's suppose we have grid something like this. If we have it, let's suppose something like this. So if we are considering till this particular point, the submatrix, so it includes all the prefixes, isn't it? If we are considering till this particular block, it includes all the prefixes. So it is actually from the start till that particular block, isn't it? The all matrices are something like this. So from here, the intuition for prefix sum comes. Now the question is how to calculate the prefix sum in case of 2D grid. So now our aim is that we have a grid with us of, let's suppose, any n cross m size. Okay. Now we want that till any particular block, what are the number of x are present? What are the number of y characters are present till this particular block? By that, what I mean, if this is a character x, this is a character y, and this is a character y, and this is a character dot. So we can say that till this particular block, the frequency of x, or the number of characters which were x, was 1, and the number of characters which was y was 2, till this particular block. Now again, since if this particular is dot, this particular is dot, so similarly, if we try to calculate those, if I simply write it down for you all, like this is the, if we construct that this is the prefix count for x, and this is the prefix count for y, so we can populate something like this. Till this particular point, the number of x was 0. Till this particular point, till this particular point, number of x was 1. Till this particular point, it was again 1. Till this particular point, it was again 1. Till this particular point, it was again 1. It was 1 again. It was 1 again. Similarly, for if we try to try populating it for y, we will get till this particular point, it was 0. It is actually the prefix value. Till this particular point, it is 1, because you can look to this block, number of characters y which is present is 1. Similarly, till this particular block, it is 1. 1 again. Till this particular block, if you look, it is again 1, because this is the prefix, isn't it? Till this particular block, if you look, it is 2, because this is the prefix. And similarly, till this particular block, it is 2 again, because this entire grid is a prefix, isn't it? So we want to achieve something like this. If we are able to do so, if we are able to achieve something like this, so now then we can easily calculate our number of submatrices. How? We will simply just traverse over all the indices and just look up that if the values at that particular indices are equal or not. If they are equal, and the frequency count of X is at least 1, we can simply increment our answer, because that is a possible submatrix, because the first condition that grid 0 of 0 must be included is already incorporated in this, since we are constructing the prefixes, isn't it? So now our aim is to construct this prefix sub. How we can do that? Just look up. If we, let's suppose we are at a particular block, and we want to calculate the number of X that are present in this particular block. So can I say that the answer for this particular block, or the number or the frequency of X for this particular block, is nothing but the number of X that we got till this particular block? If let's suppose it is X1, the number of X that we got till this particular block, let's suppose it is X2, minus the number of block X that we got till this particular block, which is X3. And why I am able to say that, just see. When I was calculating the answer for this particular block, can I say that it was nothing but the number of X till here? Like number of X in this particular block, isn't it? When I was writing the answer for this particular I comma j, so can I say that this was the block I was considering? Similarly, can I say that when I was writing the answer for this particular block, this particular I comma j, I was considering this particular block? Can I say that? Now, just tell me, if I want to write the answer for this particular I comma j, can I say that I need to consider the entire grid for the entire block for this, isn't it? So it is nothing but this value plus this value subtracted by this value, because this value gets counted twice. While counting for this, it got counted. While counting for this, it got counted. So this value got counted twice. So can I say that answer for this particular I comma j will be nothing but the answer for, if I am writing the answer for I comma j, can I say that it will be nothing but answer for I minus 1 comma j, that is the above block, plus the answer for I j minus 1, that is the left block, minus the answer for I minus 1 comma j minus 1, that is the diagonal block. If I am able to do so, the job is done. I have the frequency count, I have the prefix frequency count till each I comma j, isn't it? Yeah. So, but if you look, if I am like, if I am at this particular block, this is the grid, and I am at this particular block, so I don't have any blocks upwards, isn't it? So the answer for this particular block will be nothing but the answer till this particular block, plus if I have the character X over here, isn't it? So yeah, you need to handle those edge cases as well. Okay. So this was the concept. Let's move on to the code. Okay. So this was the function given to you, number of submatrices, vector, vector char, ampersand grid. The grid is given to you of characters. So first of all, I took the number of rows in N and the number of columns in M. Then we have constructed two vectors for prefix count of X and Y. So vector, vector int X count and vector, vector int Y count. So for X count, we have initialized it with the grid block sum. Like we have this, in which we are taking the grid and this passing a character X to it. So this grid block sum is the function that is given to us, that we made. To this, we are passing our grid, And since in this particular X count, we want to store the frequency of X, so we are passing character X to it. Similarly, for Y count, we are passing it the same function, passing it the same greed, and passing the character Y. So first of all, let's see how this function is working. And once we have this, then the thing is like pretty easy. So let's move on to this function, greed block sum. Okay. So it contains two parameters, the vector greed and the character ch. So we have rows and columns in it. And what we did, we simply constructed a vector of vector int pre of size n cross m that will store the prefix count, and we are going to return this particular function. Now we went traversing over all the rows and columns. So for int I equals to 0, I less than n I plus plus, j equals to 0, j less than m, j plus plus. Can I say that prefix of I of j, first of all, if the character present in the greed at I, j position is equal to the character ch, that is the character whose frequency we are going to find, So first of all, we need to initialize pre of I of j with 1 in that case. And if it is not equal to that character, we can simply initialize it with 0. So that is pretty much the same, writing it something like this. Pre of I of j is equal to greed of I of j is equals to character ch. Okay, so if let's suppose I, j position is x and we are looking for the frequency of x, so pre of I of j will get initialized to 1, else it will get initialized to 0, isn't it? Now, if I is 0, can I say that pre of I of j gets added to pre of I answer of pre of I minus 1 of j gets added to pre of I of j? By I greater than 0, what we mean? That we are somewhere to the below row instead of the 0th row. Okay, we are standing somewhere over here or here. If it is, so the answer for this particular block will get added by the answer for the above block, isn't it? So pre of I of j gets added by pre of I minus 1 of j. Similarly, if j is greater than 0, that is, we are not standing at the first column. So the answer for those blocks will get added by the answer of the adjacent left block, isn't it? So if j is greater than 0, then pre of I of j gets added by pre of I of j minus 1. Now, if both are greater than 0, like as was for this particular block, so the answer for this particular block will get subtracted by the answer of the diagonal left adjacent block, that is the block of coordinate I minus 1, j minus 1. So if both I and j are greater than 0, so pre of I of j gets subtracted by pre of I minus 1 and j minus 1. And at the end, once we are done computing all the prefix answers, we are simply returning this pre. So once we do so for character x and character y, we now have the prefix count for both the characters. So we initialized our answer to 0. Go to all indexes by I equals to 0, I less than n, I plus plus, j equals to 0, j less than m, j plus plus. And if the count of x and count of y are equal and count of x is at least 1, that is count of x is greater than 0, in that case, we are simply incrementing our answer. If this condition is true, our answer gets incremented by 1. And at the end, once we are done it for all the indexes, we are simply returning our answer. So yeah, that was for the third question. It was pretty much this classic implementation of prefix sum, 2D prefix sum actually. And yeah, this is like, if you look up, this is the method to calculate 2D prefix sum. So it was very helpful. It will be a good learning experience for the ones who are not familiar with this. So yeah, try to take the maximum output from this question. Okay. So now let's move on to our fourth question and the last question for today. So the name of the question is construct string with minimum cost. So it was again a very classic implementation of tries. So the prerequisite for this question would be try, if anyone is not familiar with this, with tries. So I would try to explain it a bit, but for learning purpose, you can refer to any of the articles or all. Yeah. So coming to the question is, you are given a string target, an array of string words, and an integer array cost, both arrays are of same length. That is, the array of string words and the array integer array cost are of same length. You have to imagine an empty string S. Now, what you can do is you can perform the following operation any number of times, including 0. That is, what you can do, you can choose an index I to the range of 0 to words of length -1. You can append words of I to S. And if you are doing so, the cost of this particular operation is cost of I. So you need to return the minimum cost to make S equal to target. And if it's not possible, that is, it's not possible to make S equals to target anyhow, so you need to return -1. So let's understand the question by looking up to one of the sample inputs. So the value of target given to you is A, B, C, D, E, F. So you have the target as A, B, C, D, E, F. And the array words is you have 5 words in it. So A, B, D, E, F. So words array is something like this. A, B, D, E, F. Then you have A, B, C, D, A, B, C, D, D, E, F, and you have F. Okay. And you have also been given the cost. So the cost is 100, 1, 1, 10, 5. 100, 1, 1, 10, 5. Okay. That is, if you are using this particular word, it will cost you 100. If you are using this particular word, it will cost you 1, and so on. Now, initially what you have? Initially, you don't have anything. You have an empty string. Now, you need to construct this particular string, isn't it? So what are the possible options that you have? One thing is, wait a minute, yeah. So one thing is, what you can do is, you can first of all select this particular string ABC. So to this string S, you add ABC. Once you do so, what's the cost? The cost of adding ABC is 1. Then to this ABC, you can add this DEF. And if you do so, you will get your target string, and the total cost would be 1 plus 10, which is equals to 11. The other way is that to this string, you add ABC. Okay, the cost of it is 1. Now you add to this ABC, you add, let's suppose, D. If you do so, if you let's suppose add D, the cost is again 1. Now to this string, you add EF. If you do so, you get the cost as 5. So now if you look up the total cost, you have achieved your target string, A, B, C, D, E, F. You have achieved that. And the total cost is 7. That is lesser the cost you achieved earlier, isn't it? So the question is that you can do some operations like this as I did. And you need to form the target string in the minimum cost as possible, And if you are able to do so, just return that minimum cost. And if you are not able to form the target string by the words or the strings given in this array words, you need to return a simple -1. Okay, so that's the question for you. So how we can do this? How to think about this question? So if you look up what you actually require to do, whatever words I have formed till now, like whatever string I have formed till now, from this, I need to reach to the target string, right? I have some target string and I need to reach to this target string. So to this particular string, I need to add something. Now, if I need to do so, if I, let's suppose my target string is A, B, C, D, E, F. And till now, I have got string something like, let's suppose A, B, C, D. So to this, I need to add EF, isn't it? Now, let's suppose you have E as your string. You even have F as your string. You even have EF as your string. So which one will you choose? Let's suppose for using E, you have a cost of 1. For using F, you have a cost of 2. And for using EF, you have a cost of 4. So which one will you prefer? To this ABCD, you will prefer adding E first, getting a cost of 1. And then you will prefer adding F, getting a cost of 2, and your target string will be achieved by just extra 3 cost instead of using EF as a whole, which would have put you at a cost of 4, isn't it? Over here, you have a cost of 3. And if you would have used EF, you would have got a cost of 4. So which one will you prefer? You will prefer the first one, isn't it? Because it is giving you the minimum cost. So how to decide? You would not be able to decide by just looking at the cost of E and the cost of EF. You have two possible options at this particular state. You even have the possible option to choose E. You even have the possible option to choose EF. So to get the minimum cost, you need to explore all the options, isn't it? Now, if you are thinking of directly applying DP, if you are thinking of something like this, that what I can do is I can maintain some string. Okay, I can maintain some string, initialize it to empty. Now, every time when I am adding something, like let's suppose I have string something like this, A, B, C, D, E, F, F, D, E, E, F. In my words array, I have the string and my target is A, B, D, E, F. My target is something like this. So what I will do is I will go to each possible words. I will go to each possible words and just simply see if I can insert that particular word over here or not. What is the restriction? The restriction is that your target is ABDF. Now, if you are trying inserting ABC, you can't do so. You can't insert ABC in this string temp. Why? Because if you do so, the first 3 characters of your string will become ABC. And now, even in 1,000 decades, you can't reach to this particular target string, isn't it? So you can't choose this ABC. You can't choose DEF either. You can't choose F. You can't choose TE. You can't choose EF. So you need to go over all the possible strings and look up for the options, isn't it? Like what strings you can choose and what strings you can't. Now just imagine that you are maintaining this string and you are going over all the possible indexes. So at every index, like at every possible option, you are choosing, like if let's suppose the target string was not ABDF and it was DE instead. It was like DEF ABC instead. So what you would have done? If you look up, you have the option to choose DE. You have the option to choose DEF as well. So you don't know choosing which one you will get the minimum cost, and you don't know that if you choose DE, you will get F in your future or not. You don't know that, isn't it? But you need to look up to all the possible options. So you will at first, you will choose DEF and then look if you can form the string. Then you will look DE and you will look you can form the string or not. And if so, then what's the minimum cost? Isn't it? So you need to look up to all the possible options. So if you are directly applying DP, that is, if you're thinking that I will choose from all the possible indexes, it will result into TLE, isn't it? So you can't do something like this. So from this, you get the intuition for tries, because tries help you to find the words or the patterns in a much simpler way, isn't it? So let's see how we are going to use try over here. So let's take this same example that our target string is A, B, C, D, E, F. And we have the words A, B, D, E, F, A, B, D, E, F. We have A, B, C, D, D, E, F, A, B, C, D, D, E, F. And then we also have E, F. Okay. So how do we insert words in try? So this is the root character. Okay. This is the root of the try. Now what we do, we are going to first of all insert A, B, D, F. So what we do, we simply do something like this. We insert A, we insert B, we insert D, we insert E, and we insert F. Now at F, we know that there is a word ending. We know that there is a word ending at F, isn't it? So how can we mark that? So what we can do is, we can just say at F, we can just put forward the index at which this element A, B, D, E, F was present in this array words. And why I am doing so? You will get it once we proceed further. But in short, if I want to tell you, then I am doing so because I have in mind that, okay, for using this word ABDF, I would require some cost of I, isn't it? And how would I get that cost? By knowing that at what index this particular element was present, so that I can directly get the cost, isn't it? So that is one of the reasons that I thought of maintaining the index at the end. By maintaining the index, we also know that there is a word ending at this particular node, isn't it? Yeah. Similarly, when we insert D, and to this D, we simply pushed back the index of this particular word D, or this particular string D, which is 1. Then we insert ABC. So we have A over here, we have B over here, and then we simply insert C. And to this C, we simply push back the index at which this ABC was present, which is simply index 2, isn't it? Now we insert DEF. So D is already there. We have E, we have F, and we know that we have a word DEF, which is present at index 3. So we simply push back 3 for this node F. Then we have string EF. So we have EF something like this. And at F, we know that there is a word ending. So there is a string ending. So we simply push back the index 4. That is the position of this word in this array words. Okay. So this is a slight modification, that is inserting the index. This was a slight modification that we made to our try. And now the things will be like very much easy for us once we move forward. So the ones who don't know how we insert words in try, this is something that we do. Like for every node, we have only 26 possible characters, isn't it? Like from every possible node, we have 26 possible options. We can either move to A, B, C, D, E, F up to Z. So if we had the word A, B, C, D, E, F, so we inserted that. Now, if we again have the word string ABC, so we are not from root, we are not going to insert A again, because we know that we have already inserted the A. So we simply move on to A. Now we have a B, we move on to B. Now from B, we have made a traversal to D, but we haven't made a traversal to C. So we need to make a new node C. And now we know that since a word is ending at C, so in tries, what we generally do, we mark this by something. But in this question, we are simply pushing back the index of this word ABC in the array words. That will be helpful for getting the cost. Okay. So this is how we are inserting the strings in the try. Now coming back to the question that now, okay, we have inserted all the words to the try. Okay, nice. We also have for all particular words at the end, we also have that at what index it is present in the words array. That's great. But how to now achieve the target string? That's the question for us, right? We need to know this target string, how we can get that. So taking on the same example, the target string was ABCDEF. Okay, ABCDEF. So now for using this, for getting to this target string, I am going to use DP. And what DP of I is going to tell me? DP of I is going to tell me that what is the minimum cost I require to form the target string with first I characters. That is, what will DP of 2 tell me? DP of 2 will tell me that for constructing the string AB, what's the minimum cost I require? Similarly, DP of 3 will tell me that for constructing ABC, what's the minimum cost I require? Similarly, DP of, let's suppose 4 will tell me that what's the minimum cost I require for constructing ABCD. So can anyone just guess that what will be the answer? What will be the final answer? The final answer will be DP of n. The final answer will be stored in DP of n, right? Because we require that for constructing the entire target string, what's the minimum cost required? And when we are saying that we want to construct the entire target string, we are talking of string of full length n, isn't it? So the final answer will be DP of 1. And can anyone guess that what will be dp of 0? Yeah, you guessed it right. dp of 0 will be 0 because for constructing the string of length 0, you don't want any cost, isn't it? So dp of 0 will be 0. Now, how you are going to proceed? What will be the transition for this dp? So we want the string A, B, C, D, E, F, isn't it? So what we will do is, we know that, okay, we are going to traverse over all these particular indexes that, okay, till this particular point, if the string, like before this particular point, if the string is constructed, so from this particular index, what will be the cost? Like what I will do, I will simply run a for loop from 0 till I less than n. That is, if till this particular index I, like if my I is this, so if I am traversing my for loop from this index, this means that I already have constructed the string ABC. I already have this with me. Okay. So now tell me, what is the logic? Like, what is the thing that I already have this string? Like, I already have 3 length string. How can I know that? This index I is 3, right? So how do I know that I already have this string with me? Can I say that if I initialize my all dp with 1e9, because I know initially for constructing the string of length I, the cost is some maximum value. You can initialize it with either 1e9, int max, or something like that. So I know initially the cost is maximum, isn't it? Now by coming to the index, if I get that, okay, dp of I is 1e9, what does that mean? If I'm getting, by coming at D, if I'm getting that dp of 3 is 1e9, what does that mean? That means that we are not able to construct a string ABC by the strings given in the array words, isn't it? So we can't proceed further constructing the string from D. We don't have ABC with us. How to start constructing from D? We can't do that. So in that case, we will simply continue. That is, if dp of I is some equals to some maximum value, that is, let's suppose 1e9, we will simply continue. We can't start constructing our string from this particular point. If this is not the case, if let's suppose we already have ABC with us, dp of I is some positive value less than 1e9, if that is the case. So now I would simply start constructing my string from D. Okay. So what I would do is, I would first of all take D. Now, what's the beauty of try? Beauty of try is that it tells me that whether there is a word ending at that particular word or not. Like if I tell you that I'm starting with D, just assume for now that you already have constructed the string ABC. Its cost is already present in dp of 3, that is dp of I. And now you have started constructing your string from D, character D. Now you start constructing from D, so your current character is D. Okay. Now if you look up to the try, so what you have? You know that you already have a word that is ending at D, isn't it? You have that because in this D, you have pushed back this index 1. You already know that you have a word ending at this particular index, isn't it? So what I can do is, I can say that, okay, my friend, if I know that I have the value of constructing the string ABC, I know that I have a string D in my array words. So I can simply write dp of I plus len of this word, which is 1. That is in this, if I talk of for this particular case, so I can simply write dp of 4 is nothing but dp of 3 plus cost for using this particular string. And for this cost only, we have kept that index, isn't it? So it is, this string D was present at index 1. So we know that the cost is dp is cost of 1. So can I write something like this? That for constructing the string of length 4, the cost is, okay, this is one of the possible option. I also need to take the minimum of the earlier value. So what I would write is, dp of 4 is nothing but the minimum of the earlier value, if earlier we were able to form it. So the earlier value, comma, dp of 3 plus cost of 1. If I am able to do so, so I know that for DP of 4, I can get, like, if out of the multiple options, I can get the minimum value, isn't it? Now I shouldn't stop here. I should not stop at D. Why? Because there can be more possible options as well. It may be that I am getting DE as well. I am getting DEF as well. So I should not stop at D. I should simply shift it to D. I should simply shift to character E. If I do so, now in try, just look up, do we have DE as our word? How do we know that? We know that for E, we don't have any values pushed back as the index. So we know that there is no word or there is no string that is ending at this E. So we simply move forward. Once we move forward, now we move forward to F, that is in the target string, the next character is F, and to this E, we have F inserted, right? So we move on to our next character F. We simply move on to F. And now we know that we have a word or a string that is ending at DEF, so we can take it, right? So what I will write for this particular question, if for this particular example, if I write it, so I can write that DP of the length of this word is 3, and we started from a 3-length word already constructed. So we can write that DP of 6, that is at the end, we will have a 6-length word, right? The 6 is nothing but I plus length of this particular word, isn't it? So DP of 6 is nothing but mean of DP of 6, comma, the cost till constructing the first 3 letters plus the cost of using this particular word. So for this particular word, what we know, the index of this particular word is 3, isn't it? So the value that will get added is cost of 3, isn't it? So we can write DP of 6 something like this. And even after this F, if we have any character in target string, and in tries we have the similar character inserted in this node F, so we can simply move forward and look up to all the possible options. Once we do that, once we have that, so at the end we know that DP of n, if there is a possible option, if there are possible options to construct the target string that is of length n, so DP of n will contain the minimum of all the possible values. And so at the end, we can simply return DP of n, isn't it? So yeah, that was the main like idea or the intuition behind this question. That the idea behind using tries was that it makes us easy for us to find the words, to search the words. And the idea of using DP was that we need to explore all the possible options. So to do that in the optimized manner, we need to use DP as well. So it was a very classic implementation of tries plus DP. So now let's jump to the code and understand how the solution, like what all we need to write. So I will just go through once the tries implementation, but you can look up to any of the articles or all for tries and you will get the same result. Like this is one way which I took from online platforms only, and you can consider any other platform. Okay. So what you have, first of all, I constructed a basic structure of the node. So for the node, what we have two things. First of all, the indexes of the words that are ending at that particular index, at that particular node, indexes of the words that are ending at that particular node. For that, we constructed vector in word ends. And we also have that for that particular node, what all nodes, that is for a particular node, we have 26 possible options, right? From A, B, C up to Z. So what all nodes are already constructed. For that, I simply made a map of character, comma, tree node star, because the structure will be the same for every node. So just maintaining the pointer for that and the variable child. Now coming to the try. For try, we have one whose structure is the same as this tree node. So we just did tree node star root. Then we made the constructor. So this constructor try just initializes root to tree node. This is actually the way of initializing the tree node actually. Okay. Now we are inserting the word. So while inserting the word, we are passing the word itself and the index of that particular word in the array, isn't it? So in just passing the word, initializing our node to root, Now going over all the characters of the word, if that particular character is not inserted yet in that particular node, so in that case, that is if not node of child.count C. So in that case, we are just making a new tree node for that particular child, else we are just shifting our node. That is, if we let's suppose have if we are at A currently and we want to insert word ABC. So if we have characters E over here, characters F over here, but we don't have character B. So for inserting this particular word, we have to make a character B. We have to make a new node for B, isn't it? But if we, let's suppose this was the initial structure, and now if I tell you that to insert ABC, so you are currently at A, now you want to go to B, so you don't have to make a new node. You only need to, if initially your node is pointing towards A, so now your node should point towards B. And once you want to insert C as well, so just make a new node C, your node will point over here. And now you know that this particular node, at this particular node, there is a word ending, that this particular word ABC is ending at this particular node. So in this, you need to simply push back the index of this word ABC. So at the end, we know that the node is actually pointing towards the last character. So for in the words end vector of this node, we simply push back this particular index of this string word. Okay, so this was the implementation of try. Now coming back to the question, if you look up, first of all, in our n, we took the size of this target. We constructed a DP of size n+1, where DP of I is telling you that what is the minimum cost required for constructing the first I length string of this target. Next, we just simply made a try T, and to this T, we inserted all our words along with their indexes. Okay, so T.insert words of I, comma I, and we already have this insert function made in the try class. Okay. Now we traverse over all, now we also initialize DP of 0 with 0, because we know, as we already discussed, the cost required for making a string of length 0 is 0. Okay. Now we traverse over all I from 0 to n-1 to see that if we already have the string of length I, so for further constructing the string from there, what's the cost required? So if DP of I is 1e9, that is the initial value that we initialized with, if that is the case, can I say that I don't have the initial I letters of the string target yet constructed? It's not possible for me to construct the initial I letters. So I can't now start proceeding further. I can't start constructing my target string from the index I. So in that case, I simply continue. If that is not the case, that is the first I letters are already constructed. That is from index 0 till I-1, the string is already constructed. It is possible to do that. And we are now standing at index I. So from I, we will now start constructing. So we just initialized our node to the root of the try. And now we simply start constructing from index I to all further till less than n. If the node of child.count target of j is null, that is, you don't have the further character. That is, if let's suppose you are thinking of constructing, you already have ABC, and now you are thinking of constructing DEF. You started with D, but you don't have DE in your try inserted. You don't have any words called DE inserted in your try. So you can't proceed further, right? In that case, you need to break. So if not node of child.count target of j, you need to simply break. If this is not the case, simply shift your node to that particular character. Now, if there are any indexes that are ending at, if there are any words that are ending at that particular character, so what we did, we simply traversed over all the index of this particular character node. All the possible indexes are already inserted or pushed back in word ends vector that we already know. So we simply traversed over all the possible indexes. And if we are considering that word, considering that word, that is I plus L. L is the length of that word. And how we get that length? We already know the index. So just go to that word's vector and take the size. So we know the length of that particular word. So we started constructing from I, that is from index I. That is, if we are starting constructing from index I, this means that we already have I length word, isn't it? Because this index I is 0 based indexing. So we already have the I length word. So if I plus L is less than equals to N, if this is the case, so can I say that dp of I can write dp of I plus L as minimum of dp of I plus L, comma, by we are reaching to this I plus L using this particular word. So we can write dp of I plus L is minimum of dp of I plus L, comma, dp of I, that is the cost of constructing the first I letters, plus the cost of using this particular word. So which is stored in the index, this particular index idx of cost vector. So I can write dp of I plus L as minimum of dp of I plus L, comma, dp of I plus cost of idx. Once I do so, once I am end up for all the i's, so I know that if dp of n is still 1e9, this means that I can't form any I can't form the string target by using any combination of the words given in the words vector. So I will simply in that case return -1. That is, if dp of n is not equals to 1e9, I will simply return my answer. And if it is equals to 1e9, I will simply return -1. That is, I am not able to form the string target. Isn't it? So yeah, that was the implementation for this. So the major topics of focus for this particular question was tries, a slight modification of tries for why that we are inserting the indexes, so that we know that if a word is ending, so which particular word is ending, that is what's the cost of using that word. Okay, and then dp for sure for exploring all the possible options. Okay, so yeah, that's all from our end. Hope you all got it. Yeah, thank you.